the critical t-score, right? So on a student t-distribution, we're going to find the critical t-score that is needed for a confidence level of 95% with a sample size of 30, and then for a confidence level of 99% with a sample size of 100. And I'm going to do it with the table, and I'm going to do it with the calculator. So first things first, right? If I have, obviously, my critical t value is this, right? This is the notation. This is what I want to find. So we need alpha, right? And alpha can be found by, the complement of the confidence level. So 1 minus 0.95, or in this case, 0.05. We're always cutting it in half for confidence intervals. So take your alpha, which we just found to be 0.05, and cut it in half. And you get 0.025. My picture, right? Student t-distribution is still symmetric and bell-shaped, but I'm going to label it t-distribution. The center is still 0, but the standard deviation varies for this, so I'm not, it's not the same as SND. What else do we need for a t-distribution? Again, the width and height of it varies dependent on sample size, so you need to ask what are the degrees of freedom. And degrees of freedom are always n minus 1. So in this case, our n is 30. So 30 minus 1 is 29. So my critical t-score, t of 0.025, this is what I want to find, is located here, right? Separating this area from the rest. This is the positive critical t-score. And this area corresponding to that is 0.025. Two ways to do this, right? So the first method that I'm going to use is using the table, if you guys don't have the calculator trick. So I'm going to the table now, right? So I'm looking for area in one tail or area in two tails. Both of them are going to be the same column. Degrees of freedom, I have all that. So my area in one tail is 0.025. So my area in one tail is 0.025, right? Right here. My area in two tails is 0.05. Well, that would make sense because if I were to put another area here, since it's symmetric, it would match this. And then if I add the two together, I would get 0.05. So you could look at it either way. Area in one tail is 0.025, or the area in two tails is 0.05. My degrees of freedom were 29. So I'm in the middle column of my table. And degrees of freedom are 29, so I'm down here at this row. So matching, right, lining it up, 29 degrees of freedom, area in one tail is 0.025. I get 2.045 for my critical t-score. So for this one, 2.045. Now this is again using the, the table. But I can also use the calculator, right? Those of you that want to use the calculator, by all means. You'd be doing inverse t, capital T technically, right? Inverse t. The area to the left, right, always is next. The same thing as inverse norm. I have the area to the right of the value that I want. So to find the area to the left, I do 1 minus the area to the right. And then you always input degrees of freedom next to that, which in this case is 29. So when I go to my calculator, where do I find inverse t? I'm going to find it same place that I find inverse norm, second bars in distribution, and it's actually right under inverse norm. So be careful you don't use inverse norm by accident. Inverse t, my area, right, was 1 minus 0.025, and my degrees of freedom were 29. And I should get the same thing, 2.045, obviously rounded to 3 digits to the right of the decimal. Okay, so this is my critical t-score for this particular situation.